This is a complete kit. So here you can see the EM18. This is a RFID reader which is going to read the uh, complete data from the RFID cards. So this one is a microcontroller part which is interacting to the LCD, so as well as to the controlling PC, because we have to send data to the server, right? So controlling PC. So this is a RS-232. So this RS-232 is sending data to the PC. So for this we are giving input from the controller, and while receiving from the PC or external device, so the first RS-230 will receive the data. From there we will receive it to the controller. So after receiving it to the controller, we are sending it to the LCD. So this is a LCD which is a 16 by 2, means 2 rows and 16 columns it's having. And so this is the transformer. So here you can see the two type of colors. So this blue color indicates 12 volts, this red indicates 0 volts, and again this blue indicates a 12. 12 0 12, this is the center type of transformer. So that we are giving it to the microcontroller and other peripherals, whatever we are going to use it. So this cable, I have given a 3-pair cable. So this one is how to connect is the middle cable, it should connect to the red one, and whatever the other cables, it can be connected anywhere anyway. So the red must be connected to the so middle cable. And so if you see here, so you will be seeing one port that is called as a DB9 connector. So this is a DB9 connector, it's having 9 pins, so which is going to send a serial data. So I given a output port here. So this can be connected through this one, because for our laptops we don't be having serial data directly. So what I'm doing here is this is a, you can see here, this is a mail connector DB9. So this is converting RS-232 to USB. So what we are doing is so this one is connected to the PC USB port, and the drivers already installed in this PC. So whenever you connect that one, so if you go here like a device manager, so if you open a device manager, and you will be having a column as a ports. In those ports you can see profile USB to serial port, COM6. So the most important thing we have to know down here is our kit is going to interact with this PC with a COM6. COM6 is our communication port ID. Through this port ID only we can able to communicate through our kit. So it's connected to the USB, and other end of the RS-232 is connected to our kit. See, I'm going to connect it like this. So this one is connected now. So this is the serial data interaction while transferring and receiving, and this one is connected to the USB. This is our power card. So power card we are going to plug it. So once you plug in, so you will hear a beep sound, as well as some scrolling will go. After the scrolling, it shows the PDM, patient data monitoring system. PDM indicates patient data monitoring system. So you can see the indication there. And here you will see the one LED, that's a red color LED that indicates that so you have powered up the device. And this is a swiping part. If you want to open it and see, so open very slowly. So first switch off it, and then open this one. This one will be easy to removable only. So you can see here, so it's having a notes. whatever the nodes it's having. So one side it's having 5 and other side it's having 4 nodes. So that specifications you can see here what it indicates. Okay, and you will be seeing one gold color wire, that's a copper wire. So that is wounded uh, for the 125 kilohertz RFID reader. So once you connect this one, what's going to happen is it's going to send a supply to this module. This module having a frequency to binary converter as well as one uh, copper cable that will act as an antenna. If you see this code, this is RFID code, whatever I written in a blue thing, so that is the number of unique number of this RFID card. So once when you swipe it, you will see, let's see, that's a green color LED is going and one BP is coming. So that's the indication. So directly the data is going through RS-232 to the PC. We are not yet operating our kit, just I'm explaining how the kit is going to work. And here you can see microcontroller. So it's a 8052. So the difference between 8051 and 52 is it's having 8K programmable memory. There we have only 4K. 8052 having 8K and it having 3 timers, and this is a capacitor. So this is a resistor. This combination, this capacitor positive is connected to VCC and a negative and resistor other end is connected. So the combination of the connection of these two is given to the ninth pin of the microcontroller. Ninth pin is a reset, and other end of the resistor is given it to the ground. The thing is, as soon as the power you apply the power, so the capacitor is going to, at time t equal to 0, capacitor is a open circuit, so that we are power upping means the ground is passing to the reset pin. Once the after t equal to 0 seconds, the capacitor is going to slowly charge. Once it's charged, it's having a full signal. So here with this combination, what we are getting is we are giving one edge signal, 0 to 5 volt sharp edge. When you get a sharp edge, so then the reset will happen. The reset will happen means, so it will clears the all the memory, it clears the all the memory and points to the 0th location in the stack. So this one what you are seeing, so this is a crystal oscillator, it's having 11.0592 megahertz, and this is connected to the 18 and 19 pins. Other as parallelly we have connected to capacitors, that's a 33 picofarads. So because to avoid the short circuits, so these four capacitor is connected to the RS-232 for clipping and clamping purpose to change the voltage levels. And you will be seeing here two diodes. These two diodes is connected to the transformer. Here you will be seeing three cables, right? So the middle one is a ground. These two cable, that other two cables are connected to these diodes. So these diodes are shifting the power cycles, and here you are getting a, at this point you are getting a pulsating DC. This pulsating DC is converted to pure DC by using this filter. This is a 1000 microfarads capacitor. So this side is negative, it's connected, the negative terminal is connected to the middle of the transformer center tap pin. So this is a common now. So after that, after this diodes, so and this capacitor positive, we are getting a 12 volts. That 12 volts we are directly giving to the so RFID module. And for the internal purpose, I am using one regulator. It's having 7805. 78 indicates positive, 05 indicates the 5 volts. If you want 79, actually 9 volts, 7809 is the IC number. It's having 3 pins. If you see here, the first pin is connected to 12 volts, second is connected to ground, third one is a 5 volts. So whenever the voltage is increased greater than 5 volts, it's going to cut off, and always it's like a 5 volts. And you can see the variable resistor. This is I will explain later. For the purpose of LCD, we are using this one because on the screen brightness adjustment I connected this one. So other than that, this port 2 dot 2 and port 2.3 to port 2.7 is connected to the LCD. So that's the reason it's a displaying even. So whatever the data PDM system. so that is controlled by the microcontroller. So this one is connected to the serial data. So now what I'm going to do is so if you see here, so I will be having my application here, so service upload.txt. So as soon as you open, the first important thing is you will be seeing a comport. So my comport is 6 because I already shown you that from the device manager ARKit is connected to the comport 6. So by default I given it to the comport 6. So if you see comport 1 or comport 3, directly you can enter here. So by removing this and re-enter it. So once you press this one, so this is a issue RFID card to the patient. This is the first time when the patient is joined to the hospital, so you have to assign with some RFID. So that will, this is the tab, and the other tab you will be seeing update the patient details. Once the patient is details are updated entered, if he is having RFID card, directly we can update the details like so whatever the drugs we used, if we want to add some diseases, or if we want to pay the fee, everything, this second option. These are first time users, so you will be seeing all the names. I'm giving John K, others are given UK, and RFID, so that you should enter whatever we have, whatever I written in the card number. It's a 530070 so I am entering the same thing here, 530070. So capitals also must be entered, 0 to D, and the fee is he paid 123 pounds, and the remark is he's having, let's take as a HIV, so gender is male, and allotted room is 567, and the disease is he's having two diseases. So I enter drug name, so we have given is HGF for 456. So I'm updating this. So whenever you press this, so issue RF card to the patient, as soon as you press in LCD, you will be seeing some message, the same thing whatever it also shows the port number. Once you upload it, update to the, when you press it, so the data, you can see the pop-up, data uploaded to the server, and you can see here and here. So what's the name is equal to John, whatever we entered the name, so that's displaying here. Okay, so whatever the name, so for this person we have allotted the RFID code, the details are showing here. So what we are doing exactly here is, so we are taking the details here, and you will be seeing one patient details.txt, there we are updating. So H is starting field for identifier, so second one is RFID code name and separated with the dollar, his name separated with address, sorry, address is separated with dollar, and then amount is separated with dollar, and disease is separated with dollar, gender is separated with dollar, and the room number is separated with dollar, and whatever the diseases he is having and drugs. So this is the way how we are saving it. So as soon as so you click this one, what it's doing is it's saving it to the text file, like it's a appending, so it's not overwriting, it's a appending into the text file, and then it's a sending it to the server. So I have a one server here, so I will be having one server, it's my own server. So just I'm sending it to the server, I have purchased it, so it's sending it to the server. So once it's forwarded,